So we're going to solve some related base problems, and these are going to be done without a calculator. So anytime you have bases that are related, we shouldn't be using a calculator to solve them. So example here, we have log base 3 of 27. This means that this base here, base 3, and the argument 27 have a common base of base 3. And so we can solve this using this common base without you having to rely on a calculator. So if I let the log base 3 of 27 equals x, so x would be the answer to that log, we can put it back into exponential form, and we can see, yeah, 3 to the power 3 equals 27, so that x must be equal to 3. So we can either solve this in the log form or the exponent form. An alternative to this would be to do this. Log base 3 of 3 to the power 3. Well, if I look at my identity here, if I have same base and the base is in the argument the same, that exponent must be the answer to that log. Well, that's true then. This must be the answer to the log. Okay, so we get log base 3 of 27 is equal to 3. So either or, it doesn't really matter if you do it in the log form or exponent form. We need to be able to solve this using our power properties. So here I'm just going to do the exponent form because I think the exponent form might be easier. 2 to the power x is equal to 32. I can express 32 as a power of 2. It's going to be 2 to the power 5. I can use a property that if the bases are the same, the exponents are the same, so I get x equals 5. Some of you may be getting comfortable with this log form and to understand that, yeah, log base 2 of 32, the exponent on base 2 that gives me the number 32 is going to be 5. Okay? In log form, you could have done it like this, 2 to the power 5 instead of 32, and then use the identity to make that equal to 5. The log and exponent undo each other. So same thing here. We could do it either in the exponent form. Okay, so this is going to be 5 to the power x equals 5 cubed. So we know that x must be equal to 3. Okay, or we could do it again, we can do it in the log form. I think maybe it's easier to do it in the exponent form as we're more familiar with exponents. And this last one here, we can make that equal to x. Now one thing you have to be very careful with, and you're going to be tested on this, is don't do that. Okay, because this implies that the base is a, not 2a. We have to make sure that we put the base in brackets. There's a two-part base. Okay, now the base is 2a, and then I end up with 4a squared. Okay. Now 4a squared can be expressed as an exponent on 2a. That means that x is equal to 2.